today we are going to be talking about life cycle assessments. We are going to state the stages of a life cycle assessment, explain the importance of a life cycle assessment and the limits, and then you are going to do your own life cycle assessment on paper bags versus plastic bags to see which one is best. So let's just try and think about what a life cycle assessment might be. Here is a box of cereal. What I want you to do is take a minute or so to write down all the materials, all the ingredients that you think go into making a box of cereal. Off you go.
So this was my breakfast choice this morning, and we can look at both of these cereals and what has gone into making them. So I had Weetabix, cardboard box. Inside your cardboard box, because I got it out earlier, you've got this kind of plasticky, papery material, and then inside you've got your Weetabix. Don't ask me why I've left a half. Wheat, obviously grown probably in the UK, processed in a factory, mashed down, shaped into lovely little oblongs. So that's your Weetabix box. Now, you'd have thought the cornflakes would be fairly similar. We've got a cardboard box again. Inside, you've got your plasticky packaging. So it's made of a slightly different material than what we had first. And then your crunchy nut cornflakey things inside. A few more ingredients for this one. We've not just got wheat from before. This time we've got corn and sugar and peanuts and honey. So a few more ingredients have come in. Just have a think about where all those different ingredients have to come from.
So a life cycle assessment works out the environmental impact of each stage of a product's life. So in those two cereal types of cereal there, we had different ingredients, and that would immediately start to change the environmental impact for each of those individual cereal boxes. Now there are four main stages for a life cycle assessment. Stage one is extracting and processing the raw materials. So that will be any ingredients or any chemicals that are needed to make the product, as well as any ingredients or materials for the packaging as well. Stage two is manufacturing and packaging that product. What has to go into actually turning those raw materials into the product, and how is it then packaged up in a factory. Stage three, how will that product be used over its life? Is it a one-time use? Does it have multiple uses? And stage four, how is that disposed of at the end of its life? Is it going to go to landfill? Can it be reused or recycled? Within each stage, you must be thinking about the transport and distribution. Extracting and processing raw materials will involve transport and distribution. You've got to move those raw materials to a factory to make your product. You've got to move your product to a shop. You've got to move your product from the shop to the consumer. And you've got to take your finished product to wherever it's going to go to be disposed. We're going to watch a video now back at our cereal boxes to have a little look at the ingredients, the materials used, and then how it might be disposed of.
So during the life cycle assessment of any product, there are multiple stages. Now we could take any one of those stages and really look at it in depthly. So let's just concentrate first on the ingredients. This is pretty much one ingredient. If we have a look on the back, it's mainly wheat, 95% wheat, a little bit of barley, some sugar, some salt, and some added vitamins and minerals. So the wheat there would have been grown in the UK, as far as I'm aware, judging by the food standard awards and things that it has at the bottom. Barley as well would have come from the UK. If we look at our Co-op corn flakes, We've got many more ingredients compared to our Weetabix. It contains maize, which is corn, brown sugar, peanuts, sugar, honey, salt, sugar syrup, malted barley, and then also your added vitamins and minerals. And if you look underneath, yes, it's made in the UK, but it uses Argentinian or Hungarian maize, so that's had to be imported, and American or Argentinian peanuts. Again, that would have had to have been imported. So the life cycle assessment for these two products, the Weetabix is more local. So we've saved on transport costs to get the ingredients to where they need to be. It uses less ingredients than the cornflakes. And so overall, doing a life cycle assessment just on the ingredients, I can already start to make a decision about which cereal I might be more likely to buy in the future, which one might be more economical or more environmentally friendly. So let's now look at the packaging stage of our life cycle assessment. We'll start with the Weetabix again. So the box, as we said before, made of cardboard. This is kind of, it's not quite paper, it's got like a shiny plasticky film on the inside. So they've done that to keep it fresh. The Co-op one, also a cardboard box, so really not much difference there. And then you've got your sort of plasticky bag, which is recyclable. You can take that and recycle it where you recycle your other plastic bags, whereas this is not recyclable. Okay, so already we've got recyclable cardboard, recyclable plastic wrap, non-recyclable wrapping on the Weetabix. If this was recyclable, if this was just paper, then that would change your life cycle assessment. Okay, it will make this life cycle assessment more environmentally friendly. You'll notice that I'm not using any numbers. There's no way of really quantifying the assessments for each of these different types of packaging, mainly because it's too complicated. There's so many different variables that can come into play when talking about a life cycle assessment. The environmental impact of every single ingredient or every single material being used, how that might be disposed of, whether it can be recycled, whether it has to go to landfill. These are all things to take into consideration. Therefore, we cannot give an actual value of a life cycle assessment. It's just really our own judgment. Disposal of a product is also really important when thinking about a life cycle assessment. It's the final stage of that product's life. What's going to happen to it once it is used? Here's my recycling bin. So you can see there's quite a lot of different materials in there that can be recycled. We've got glass, we've got different types of plastic, we've got cans, and then we've got cardboard, different types of cardboard, and different types of paper as well. As well as recycling, you've got other types of disposal, like a food waste bin or a compost bin. Ooh, you don't want to see that. And of course then you've got your normal, your black bin, your landfill waste. Even better than disposing of a product at the end of his life is reusing. So reusing is always better than trying to dispose of something, because there are costs involved with disposing, and I don't mean necessarily monetary costs, but also environmental costs. So in my house we reuse as much as we can. Things like pots. I keep lots and lots of pots, especially those butter pots. They're really, really useful. We keep jars. There we go. Top of my horrible cupboard. Keep all my jars, wash them out. And why do I do that? Well, very good question. Because I like to make some jam. I've got a lot of jam in there. Okay, and that jam is made using local apples, blackberries that I've picked from my garden. So that's a really good life cycle assessment.
So So just between two different types of cereal boxes, you can see that the life cycle assessments are already quite varied. The way that we analyse the impacts of each of those stages is also quite complicated. The materials that are used to make that can be produced in different ways. So cardboard obviously comes from trees, the plastic packaging will come from crude oil. They both will have their own processes which take different amounts of energy or create different amounts of waste. The size of the packaging is quite similar, so actually it's quite an easy one to compare when thinking about the size of packaging and transport, because both will be transported in about the same quantities. So if you compare those two cereal boxes, the transport cost will be about the same for each. But then of course it depends what you're using, what type of transport you're using. You might be using fully electric vehicles, or you might be using diesel vehicles, and that will change your life cycle assessment. Using or reusing, well, it's both cereal, so it's going to be consumed, it's going to be eaten. So again, they'll be fairly similar. And then disposing of your packaging at the end. Some people may put their packaging into landfill, some people may recycle it, some people will recycle the plastic bag inside, and some people won't. So it's another thing to bear in mind when talking about life cycle assessments. So just between two types of cereal, we can see there's lots of differences. Now, what about plastic or paper? Plastic bags versus paper bags. So the government are trying to reduce the use of single-use plastics, and one way of doing that is to ban the use of plastic bags at supermarkets. Many supermarkets will still have plastic bags, but they charge them, and this is trying to limit the amount of people buying the plastic bags and trying to encourage them to use their own. Some shops have moved to using a paper bag instead, where they don't have to charge the customer. But which one is really better, a paper bag or a plastic bag? We are going to find out. Now, attached to your to this video on EduLink, you will have a few resources. One is a table that looks like this. So we have our plastic bag here, our paper bag here, and our 4 main stages of our life cycle assessment, including our transport and distribution. Using the resources attached, or the wealth of the internet, you are going to put a description into each of these boxes about what is involved within each stage, thinking about the environmental impact as you go. When you are finished and have filled in your table, you are going to give each stage a score out of 10 for environmental impact, with 10 being the most serious impact, the worst impact, and 1 being the least impact, so the better for the environment. And then I want you to calculate the stages for each bag. So pause the video now and take your time to complete this table so that it's full of lovely information, and you can make a really good judgment about the score you're going to give each stage. So well done for filling in your table. Here is one that I've done earlier. So if we just have a quick look at our descriptions for each, some of them are quite similar. So our transport and distribution, both of them require transport to get your raw material to the manufacturer, and then from the manufacturer to the shops. So there's not going to be too much difference in your transport type here. Manufacturing and packaging, again, processing the raw materials, cutting them, every stage of that uses energy. Both will be packaged in some kind of cardboard, so I've given the same score for manufacturing and packaging. The other stages is where we start to see our differences. So extracting and processing the raw materials. Plastic bags comes from crude oil. Crude oil is a finite resource, one that we're going to run out of. It requires fractional distillation and cracking in order to get the polymers to make the plastic. There's a lot of energy involved in all of those stages, but there's not that much waste, which is quite a good bonus for plastic bags. Paper bags, however, it uses wood, it uses timber, which is a renewable resource, so we can plant more trees, but it requires a lot of wood per paper bag. You have to pulp it, you have to process it. Again, also requires a lot of energy, and there is also a lot of waste, which is why the score is a lot higher. It has a more of an environmental impact than making a plastic bag. Using and reusing. Now, a plastic bag, generally pretty strong, and you can reuse it many times. So actually, whilst it's being used, it doesn't really have an impact on the environment, so it gets quite a low score. The paper bag, generally, you can only use once. Now, you can argue about this, and that is all part of life cycle assessments. So I would argue that I've had paper bags that I've used 3 or 4 times, okay? But that is part of doing a life cycle assessment, and we will come to that in a minute. And finally, disposing. So both are recyclable, you can recycle both, but plastic isn't biodegradable, whereas paper is. And the biodegrading of paper is much better for the environment than having tiny little bits of plastic floating around and entering food chains. It takes up a lot of space in landfill because it takes such a long time to break down, whereas paper bags will break down fairly quickly, so not take up much room, and they don't really cause any pollution. Any carbon dioxide that is given out is what they took in over their life, so it's carbon neutral. So I've scored these all up. Yours might be slightly different, and that's fine. Again, that's all part of doing a life cycle assessment. But key things to look at really is this big difference here, okay? If I count up my totals, 23 for the plastic bag, 28 for the paper bag. So using my judgments here, the plastic bag is actually better for the environment than the paper bag, which I find quite surprising. And it's due to those ideas that I said right at the beginning. So the fact that plastic bags take actually less energy to make in the first place, and you can make more plastic bags than paper bags within the same mass. So you can carry more. So in terms of your transport, that is going to make a little bit of a difference. The waste coming from paper production and the amount of wood needed is quite damaging for the environment. And the fact that plastic bags can be used a lot longer is also a factor. So hopefully, as we went through that, you can see that there are a few little problems with that task. It's quite hard in what we were doing to give a numeric value. You know, there was probably quite a few differences if we were to compare all of our values. However, in the real world, you can quantify quite a lot. So how much water you use can be easily measured. How much of a resource you use can be easily measured. How much energy it takes can be measured. How much waste is produced. All these things you can get a numerical value for to make comparisons a bit easier. However, you cannot look at the effects of pollution. You can't give that a numerical value because that is too broad and too complicated. You don't know what the overall effect will be, you don't know what the long-term effects will be, and you don't know how it will affect an individual area or habitat. So we have to use something called a value judgment. They are the scores that you came up with in that task. You used your own judgment to give a value, and we do this for real life cycle assessments. But obviously there's a problem with using value judgments. Have a think about what that problem might be. So value judgments are subjective, and subjective means it's an opinion. Objective, things are facts, so this is an orange. Subjective is opinion. I like oranges, or I don't like oranges. Objectives are facts, subjectives are opinions. So because LCAs are a mix of our actual numerical values and our subjective value judgments, we cannot call it an objective process. Okay, people's opinions do make a difference. So here are our 4 stages again, as a reminder. So if you were making paper bags and you wanted to advertise your product, one of these stages you might want to downplay a little bit, and that stage would be your extracting and processing raw materials, because that had our highest environmental impact. So if you were advertising a paper bag, you would talk all about disposal and packaging it and all of this, but you would not really want to advertise the fact that you were having to use lots of wood and it was giving you lots of waste. So you might give an approximation of the materials, and you might give a value judgment that was a bit more biased towards your product. What we need in LCAs is peer review, and what peer review means is that other scientists have looked at the information, reviewed it, tested it for themselves, and either agreed or disagreed with the outcome. So a peer-reviewed LCA is a lot more trustworthy than a life cycle assessment that has not been peer-reviewed. That may have been misused, they may have lied or been biased towards their products, and so it's just not as trustworthy. So you can literally say, well, I don't believe you. So to finish, with every stage of a life cycle assessment, there are environmental impacts, and we can therefore have a look at the carbon footprint of each life cycle assessment. Carbon footprint comes up in the Earth and atmosphere topic. But we should be able to use a life cycle assessment to help us come up with the carbon footprint of a product, as it's the total amount of CO2 and other greenhouse gases emitted over the full life cycle of that product. So each one of these stages has its own carbon footprint, and then we can put that all together to get the whole carbon footprint for that product. An LCA just also goes that one step further. So rather than just looking at carbon footprint, it's also the water use. As we know, water is very important as a limited resource. So how much water is being used is a really key environmental impact. Other pollutants that aren't gases, so other sort of toxic waste that could seep into the ground and affect plants, and how much waste is being produced and where that waste will then go. Will it go to landfill? Can it be reprocessed in some way and used? So that is the end of our lesson on life cycle assessments. Just remember to have each of those stages clearly written out, and that the transport and distribution is important for every single one of those 4 stages. Hope you enjoyed the video. See you soon.